Now let's go to assignment 1. We have talked about question 1, 2, and 3. Am I right? Okay. Now let's go to question 4 and see how we can answer this kind of questions. Question 4. When you are trying to discover whether there is a relationship between two categorical variables, why is it useful to transform the count into a cross table, percentage of row and count? Once you do that, how can you tell if the variables are related? How do you answer this question? Relationship between two categorical variables. We have already talked about it. Crosstab is used when we want to see relationship among multiple categorical variables. And you can plot it in a bar chart to see their relationship. That's all about this kind of question. How can you tell if the variables are related? If you see a trend among these variables, among these values, or if you see a kind of relationship between their bar chart, you can say they're related. Otherwise, no. That's the only way that we can work with categorical variable, to count or take the percentage and see if their chart is similar or not. But with numerical variables, we have multiple options. Like question 5, P355 lists the average salary of each MLB team from 2004 to 2011. Let me make sure I'm recording this. Recording using progress, yes. Create a table of correlation between these wins columns. What do these correlation indicate? Okay. Have you guys been able to download and install stat tools on your machines? Okay. So that shouldn't be a problem. So, create a table of correlation between wins columns. Okay. Again, in the stat tools, we need to define our data range, dataset manager. Okay. This is going to be our dataset. So then let's see what it asks for. Create a table of correlation between the wins columns. Okay. So now we can go to summary statistic, correlation and covariance. You want to take the correlation, and we need to select these wins, see if they are related. Wins 2007, 2008. Okay, symmetric. And correlation. And click OK. Now we can go through this table to see if there are correlations among these variables. The first row, the correlation with wins in 2004. Between 2004 and 5, we have 0.6 as our correlation. You know that correlation varies between -1 and +1. Minus something around minus and +1 means a strong correlation. Close to +1 means a strong positive relationship, something like this. Negative relationship means something, it's going to be something like this. This is positive relationship. As x increases, y will increase too. And here as x increases, y increases too. This is the negative, this is the positive correlation. Okay? 2004 and 2006. The correlation is lower than the previous year. And there is almost no correlation between 2007 and 2004. And so the strongest correlation is between 2 consecutive years, 2004 and 2005. And you can check the other variables and years the same way. Let's see. If I can find a better correlation. Okay. And the other way is to see this correlation in a scatter plot. You can go to the summary graph. You can visually see the relationship between these variables. Okay. For example, between Win 2004 and it will be our Y, and Win 2005 is going to be our X. You see, there is a kind of linear relationship and positive relationship. This correlation is not perfect, but they relatively strong. Correlation is 0.66. That's how you can check the relationship between numerical variables. It makes no sense to use this method for categorical variables. Okay? Does it make sense? And you can, what do this correlation indicate? Are they higher or lower than you expected? You can go through all those numbers and report the result. Create a table of correlation between salary columns. Now, for this part, we can again go to summary statistic, correlation and covariance. And this time, we should select salary variables. Salary. Salary for the first part. Between 2004 and 5, there's a strong relationship because the correlation is 0.9, very close to 1. 2004 and 5, 0.8, 7 to 0.8, and etc. Now we can plot it in a scatter plot. Close these files. Okay. Scatter plot the relationship among these variables. You want to see the relationship between each pair of variables. Let's see if that works. Okay. Okay. Between 2004 and 4, of course, there is this perfect relationship between each variable and between with itself. And here in this one, we have between 2004 and 2005. The correlation is 0.9. Right-click at trend line to see a linear relationship between these two variables. Here, these dots are scattered. The relationship is not as good as the first one, but it is still a linear relationship. We have some outliers like this one. These dots. And you see the correlation 0.8. The correlation is lower than the previous one. And you can check that visually with this scatter plot. Questions? Let me close this file. Go to the next part. For each year, create a scatter plot and associate correlation between wins and the year. Okay. For example, we want to see the salary of the players and the number of wins that they get in each year. There are two ways. With summary measures or correlation, we can check the relationship. We go to one variable summary. We should go to the correlation. For example, we want to check the correlation between salary of a player and the number of wins that his team gets in each year, between wins and salary. Okay. Correlation is 0.6. So there is a relationship between these two variables, but not strong. And we can check all these relationships one by one between salary in 2004 and number of wins in 2004. Oh, that's right. Salary, and I have to define it as our X. Okay. Here's the correlation. Here's the scatter plot. There are some outliers or extreme values like this one. But we can define a linear relationship between these two. We can say number of wins is related or correlated to the number of wins in 2004. That's how you interpret this data. But we cannot measure the coefficients with scatter plot or correlation. We need to use regression analysis to see the coefficient of all these variables. With this one, we can say X is related to Y, and the relationship is strong or not, something between -1 and +1. How can we measure this relationship? We need to define this kind of equation. For example, ax1 plus c, it's a constant. And for this one, we need to define a regression equation or regression model. We are not going to cover regression in this course. So correlation is all about the relationship, whether there is any relationship or not, or if there is a relationship, is that relationship linear or non-linear, and etc. This is for the third part, and you can check all these variables, all pair of variables like wins and salary in different years. Any questions about this question? Okay, let's go to question 6. The term churn, or is a switch to other service provider, is very important to manage our cellular phone business. Churning occurs when a customer stops using one company's service and switches to another company's service. Obviously, managers try to keep churning to a minimum, not only by offering the best possible service, but by trying to identify conditions that lead to churning and etc. For example, if a company learns that customers tend to churn at the end of their 2-year contract, they could offer customers an incentive to stay a month or two before the end of this month. The file contains data on over 2,000 customers of particular data cell phone company. Each row contains the activity of a particular customer for a given time period. Use the tools in this chapter to learn how these variables are distributed. Okay. Let's open this file. What kind of tool that we can use to find the distribution of a variable? You guys remember that? How can we check the distribution of a single variable? With histogram, you can check the distribution of a numerical variable, okay, whether it is symmetric or not. And to check its summary measures, you can go to the summary statistic and check all this detail about a single variable. Again, we need to define our data set, our data range. You need to click on Dataset Manager. Okay. This is going to be our data set. Now Stat Tools can identify every single variables in this data set. So for the first part, how these variables are distributed. First, we need to identify our numerical variables. Customer is a categorical, account length is a numerical, international plan is a categorical, voicemail message seems to be numerical, yeah. Day, minute, numerical. All the rest of the variables except churn are numerical. For example, We can go to the summary graph and histogram. We can check these variables: account length, voicemail message, daytime, day calls, day charge, evening minute, and etc. Non-numeric data, one or more variables. International plan, account length, which variable could be categorical? International plan. Okay, yeah, this one. Okay. So from this, histogram, you can see we have a symmetric distribution. This is a symmetric normal distribution. If it is skewed to the right, it's going to be something like this. Its tail is going to be bigger on the right side, skewed to the right, or its skewness is going to be something close to 1 plus 1. This means mean is bigger than the median, or we have some extreme values on the right. Does that make sense? That's how you interpret skewness, which means we have some normal values and we have, for the skewness, we have some extreme values or outliers on the right side. For example, if you check the salaries, for example, normal salary varies between 20K and 50K. If your diagram is something like this, it means a few people make more than 50, something plus 80K in a year. That's how you interpret skewness. And the same for skewness to the left. Its tail on the left side is longer than the right side. Means some people may make, for example, in this one, in this range. This is the normal range, and these are the extreme values, 10K and 80K. This one is for the skewness to the left, and this one is for the extreme values to the right. These extreme values are called outliers. They change the symmetry of our diagram. So for the account length, we have a normal, a kind of symmetric shape. Let's go to the other. All these variables seem to be symmetric. We don't have extreme values. And you can also check the summary statistic of all these variables, these numeric variables, like voicemail, day minute, day call, day charge, evening minute, evening call, and etc. This stat tools makes everything very simple. With just one click, you can get the report for all these variables. Mean, for example, for the day minute is this one, variance, skewness, very little skewness, median and mean are the same. With these two measures, we can check whether the distribution is symmetric or not. Whenever mean is bigger than the median, we have a skewness to the right. Whenever mean is less than median, we have a skewness to the left. Three ways to check the symmetry of the distribution: histogram, comparison of the mean and median, and also skewness. Questions? First quartile, third quartile, range, and etc. Okay. That was the answer to the first part of the question. How the variables in column B through R are related to each other. How can we check this relationship? How do you guys check the relationship between variables? Come on. Scatter plot or correlation, relationship between two variables. Okay? Between B and R. Let me close these files. You don't need them. So the relationship between these variables. So correlation is only used for numerical variables. So we can go to the correlation and covariance and define and check all the numerical variables. Account length is numerical. International plan is a categorical. Voicemail plan. Let me go up again. Voicemail plan is a categorical. Voicemail message. Day minute, day call, day charge, evening call, B to R. Charge, night minute, night call, again is a numerical, night charge, international minute, international calls, and etc. From this table, we get the summary statistic for all these variables, every single variables. But if you want to check the relationship between these variables, we need to go to the correlation and covariance and select check these numerical variables. Voicemail plan. Oh no. Account length, day minute, day call, day charge, etc. Evening call, evening charge, night minute, call, international minute, call, international charge. Churn is a categorical variable. And we just need the correlation and click OK. For the second one, how the variables in columns B and R are related to each other. From this table, we can check if they are related. For example, between they call and they charge. They call, where is the they charge? This one. There is no relationship. They call and they charge. Correlation is 0.02. And between day charge and the international minutes, for example, check international minutes. Again, there is no relationship between these two variables. It's very close to zero. Let's check these variables. The relationship or correlation is not very strong among these variables. How the variables in column B are related to churn variable in column S? We haven't covered this discussion. It's about kind of classification. So let me remove this part of the question. We haven't covered this part in our class. It's all about classification. Safe. And that's how you work with these variables. As a reminder, for single variables, we can get the summary measures. For example, for x, we have summary of central tendency, like mean, median, and mode. You can check the distribution or variance of a variable or standard deviation. Standard deviation is the square root of variance, and also you can check the shape of a variable, skewness and kurtosis. I didn't talk about it in class, so we can just check the skewness. This is how you work with single variables. But to find the relationship between two variables, two numeric variables, we need to use x and y. Take a correlation or plot the values in a scatter plot to see if they are related, if there is a relationship. Is that a linear or non-linear relationship, and etc. But to quantify the relationship between these variables, we need to use regression. You can read chapter 5, 6, and 7 of the textbook if you're interested. But I'm not going to ask you this in exam or assignments. Any questions about this part? So now you should be able to complete this assignment and submit it by September 27th. We still have 6 days. Now let's go to chapter 13. We were talking about optimization models. Let me close these files. Don't save. Chapter 13. Desktop. Chapter 13. Do you guys remember that example? Did you go through this example, its definition? That's the first example for optimization and how we should identify the variables. So for optimization, which is one of the main topics of this course, we need to first identify 4 variables. First is the objective variable. What's the second variable? Do you remember? The second variable is the constraint. Now please open this file, product mix 1. Download the files from chapter 13 folder. So we need to meet the constraints, decision variables, and we have some input variables. We want to maximize or minimize the objective variable. That means optimization, maximizing or minimizing the objective. It has to be a single variable or one cell in Excel. And we have to meet those constraints. We can change these decision variables, and we have some input variables. By changing these decision variables, we want to maximize or minimize the objective variables. And only those values must be selected that can meet the constraints. So Excel tries to check different values for the decision variable to see which one works best for the objective variable. These variables must be directly or indirectly connected to the decision variable. And as I said, it must be, this decision variable must be able to change freely, and these two variables must be connected to the decision variable. We went through this example in the last week, okay? These are the variables. We want to maximize the profit in this model. Profit equals revenue minus cost. In this example, for cost, we have three elements. We have labor, which is divided into test and assembly. This is the first part of the cost. The second part is the cost of parts. Revenue is how much that computer or that item sells in the market. So we want to find a way to minimize the cost to be able to maximize the profit. Here in this sheet, you see the cost per labor hours of assembly. Labor has two elements for testing and for assembly. The cost per labor hours of assembly is $11. Per labor hours testing is $15. Labor hours for assembly, 5, 6, and these are all the variables. Selling price is 300. Selling price is going to be the revenue. And we need to subtract all these costs from the revenue to get the profit. And numbers to produce. We want to determine how many of each of these two items to produce to be able to maximize the profit. And we have some constraints. For the hours used, must be less than hours available, and also for the numbers produced must be less than or equal to the maximum sales. We are running out of time. We don't have enough time to cover all these details today. I think I finished that example in the last week. You can watch the video of that class and let me know if you have any questions. It takes more than 15 minutes to define these variables. But let's do this. We have only 5 minutes. Okay, unit margin. You want to calculate revenue minus cost. It equals selling price, or B11, minus labor hours for assembly times costs per labor hours, B3 times B8 minus cost of testing, B4 times B9, and minus cost of component parts, B10. Okay, $80 for each basic computer, and then copy, Control V. Here's the numbers to produce. We can define it as a range. We select it and go to the formula, create from selection. Left column is going to be the name of this variable, maximum sales. The next variable, hours used. We highlight this part, and then create a variable from that, hours available. total is the objective variable. So hours used for assembly will be numbers to produce times unit margin, I guess. And you can check the defined variables from this menu. Hours available, we have defined hours used, maximum sales, maximum to produce, total. Labor availability for assembly. Is labor hours for assembly times numbers to produce. B8 times B16. And for testing is B9 times numbers to produce. Sorry, I didn't. It is the sum product of this row for assembly by this one. B8 C8 times this row, numbers to produce, B16 and C16. Now we can copy and paste it here. B16 net profit is going to be the unit margin, this one, times the maximum sales. This one equals B12 times B16 and total is the summation of these two. It must be less than or equal to this one, less than or equal to this one. The same for this one. Numbers to produce must be less than the maximum sales, less than or equal to. Now we can go to data solver. Objective is the total. What's the decision variable? The numbers to produce. Numbers underline to underline produce. We have two constraints. This one, numbers to produce, number to produce must be less than or equal to the maximum sales, The second constraint is for the hours used. Hours underline used must be less than or equal to hours available. Here's our model. For non-negativity, we need to click on this one. We select simplex linear programming and see what we get. Answer. These are the values that will optimize our result. With these values, 560 and 1200 of XP, we're going to get this value. This is the optimal value for the decision variable. This is our decision variable. and this one will be the objective variable, the maximum value of the profit that we can get from these variables. I will upload the solution after the class. So yeah, we ran out of time. I have recorded this class. I will upload the recording as well as this solution file in Box. Is there any questions? Let me